Hey everyone, welcome back. In today's video, we're starting the new concept within the chapter of states of matter, and we're going to be talking about diffusion and the factors which affect it. Well, this video is just going to talk about the role of molecular mass on diffusion. So, let's begin. First, we have to define what diffusion is. So, when we talk about diffusion, diffusion is basically random movement of particles. We used to talk about movement of particles from higher area concentration to lower area concentration, but we don't talk about it anymore. It's random movement of particles that allows them to uniformly distribute within a volume and obviously attain an equilibrium within the system. So it's a random movement of particles and they distribute themselves uniformly. Imagine you have a beaker containing distilled water and then you have a dropper consisting of aqueous potassium manganate solution, which is purple in color, right? So what happens because of the aqueous potassium manganate solution? Let's say it has a concentration of um, let's say it has a concentration of 0.100 mole per dm cube, and then within the distilled water there's obviously no potassium manganate, so the concentration is 0.00 mole per dm cube. Okay, now if I drop by drop add potassium manganate, those drops will uniformly spread themselves in the whole mixture. That is diffusion. First, let's study an experiment to understand diffusion and the role of molecular masses. Imagine I have a glass tube which is sealed on both sides, and I have a piece of cotton which is soaked in concentrated hydrochloric acid. On the other end, I have a cotton piece soaked in concentrated aqueous ammonia solution. Now, concentrated HCl starts to release the fumes of HCl, and concentrated aqueous ammonia releases the fumes of ammonia gas. These are HCl molecules on the left hand side, which are in gaseous nature, and ammonia gaseous particles are on the right side. Obviously, because of the concentration difference, the HCl particles are going to move towards the right side and ammonia particles are going to move towards the left side. You can see that they are touching each other, they are reaching towards each other, they are mixing towards the left part of the tube, not in the middle. Why would that happen? Why would ammonia particles move so faster that they cross the middle and they reach in the lefter part in the left side? Why would the white powder form and why is it forming in the left side? So question 1, what's the white powder? The white powder is formed because when ammonia and HCl combine, they form a salt called ammonium chloride. Ammonium chloride forms when ammonia and HCl react, and it's a white precipitate that you see on the left side, on the HCl wala side of the tube. But why not in the middle? Why on the side where HCl was there? See, when you find the molecular mass, HCl has one hydrogen and one chlorine atom. So the molecular mass is 36.5. For ammonia, you have one nitrogen and 3 hydrogen atoms. So when you try to find the molecular mass, it has a mass of 14 plus 3 times 1, which is obviously 17 units. So the mass of ammonia is only 17, but the mass of HCl is 36.5, almost double. That is why the HCl particles diffuse slower because of higher molecular mass, and ammonia particles diffuse faster because of lower molecular mass. So higher molecular masses cause slower diffusion and vice versa. That is why they would never meet in the middle. They would always meet in the side where the slower particles were coming slowly, but the faster particles crossed the middle part and they reached in the other region of the tube. In order to understand this, we have one more experiment. Imagine a U-shaped glass tube. It's a very thin tube which is filled with water. The water has a level of X on the right hand side and a level of Y on the left hand side. On top there is a inverted beaker And the glass tube ends with a porous spot. We call it a porous spot because the top layer is porous and gases can move across this layer. Within the inverted beaker, we have 15 molecules of, let's suppose, nitrogen gas. 15 molecule is not like really possible, but we are just like estimating it. And within the porous spot, within this square part, within this cube, we have 15 hydrogen molecules. You can see nitrogen molecules are drawn bigger because their molecular mass is 14 units. And within the porous spot, you have 15 hydrogen molecules, which are drawn smaller because their molecular mass is just 2 units. When diffusion begins, nitrogen travels slower, but hydrogen travels faster. So the velocity of nitrogen is very less compared to the velocity of hydrogen. This is because the molecular mass of nitrogen is very much compared to the mass of hydrogen. So by the end of it, only few molecules of nitrogen have moved towards the porous spot, but a lot of hydrogen molecules have moved outside the porous spot into the beaker. So now you need to read the new distribution. It's not 15-15 anymore. In the beaker now you have 22 molecules of nitrogen and hydrogen. And in the porous spot, there's only 8 molecules of the mixture, which involves both gases. So you can see initially there was equal distribution of two different compounds, but now the beaker contains more molecules because very few hydrogen left, but very few nitrogen left, but a lot of hydrogen came inside. And the porous spot has less molecules. Why does it have less molecules? Because very few nitrogen came inside, but almost all the hydrogen left because they were very quick. So because of the vacuum created in the porous spot, water starts to get sucked towards the top. So water at the level of Y will move upwards. Because the porous spot is empty now, gases have left. So a vacuum or area of less pressure is created. Why would it be a less area, area of less pressure? As the porous spot is having less molecules of gases than before. So water will be moving upwards. And obviously the water at X will start to move downwards. This only happened because in the porous spot, all the hydrogen left almost, but very few nitrogen came in. Why would it happen? Because nitrogen has high molecular mass and hydrogen has very low molecular mass. Another example of a very similar setup is when in the beaker you have 15 molecules of, let's suppose, carbon monoxide gas, but in the porous spot you have 15 molecules of nitrogen gas. Now it's a comparison between nitrogen and carbon monoxide. We need to first recall the molecular masses. The molecular mass of carbon monoxide is 12 plus 16, 28 units. The molecular mass of nitrogen gas is 2 times 14, so that is again 28 units. Since the molecular masses are same, their rate of diffusion will be same. So within a given time, the number of molecules entering the pot will be equal to the number of molecules leaving the pot. Because rate of diffusion of carbon monoxide is equal to the rate of diffusion of nitrogen because their molecular masses are same. So if 5 molecules, let's suppose, move downwards, 5 molecules will also move upwards. So they're going to cancel each other out. As a result, the volume in the porous spot remains the same. There is no vacuum, no high pressure, no low pressure created. The same volumes are still here. The same volume in the inverted beaker and the same volume in the porous spot. So no pressure created on water at level X and no pressure created on level Y. So they stay at the same level. I hope these ideas are clear to you guys. In the next video,